Okay, so in the last video, we talked about the checklist of what you need to know to get full marks for redox reactions. So I didn't go over the theory, but I went over facts that you need to know to be able to get full marks for a redox reaction question. And we went through everything, and I mean that video is our previous video, you can check that out. But we wanted to carry on in this video talking about the last two questions and then finally starting to solve an actual question. So the second question, the second last question, do you know the difference between reducing and reduced, oxidizing and oxidized? So when I say reducing, I mean in terms of a reducing agent. We said that this is something very confusing, but we said a reducing agent, it's something that is reducing something else. So if you are a reducing agent, or we can say oxygen, so for example, we say oxygen is reducing, we mean that oxygen is the one that is reducing something else. It's causing something else to be reduced, right? And the same thing for oxidizing. If we say that hydrogen is oxidizing, we mean that hydrogen is oxidizing something else, or it's causing something else to undergo oxidation. When we say reduced or oxidized, then we mean that that substance itself is undergoing oxidation or reduction. And we talked about this in the last lesson itself. For example, here you can see one of the things we wrote from the last lesson. Zinc has undergone oxidation. So if zinc has undergone oxidation, then it is reducing. It's reducing something else, but it undergoes oxidation. And the same thing for hydrogen in this example here for HCl plus Zn. Hydrogen is undergoing reduction, but it is oxidizing zinc. It is causing something to undergo oxidation. So that's the second last thing. And then the last thing, do you know how to interpret a reduction potential table? A reduction potential table is this table here. It's normally given in those information pages that you have towards the end of your question paper. And it's something that you don't need to know very well now, but something that you're going to know, that you're going to have to know in matric when you start doing electrochemistry. So electrochemistry is a subject or a discipline within chemistry that's built on knowing how redox reactions function. So this reduction potential table, as you can see here, it has only reduction half reactions. You can see that that's the case here. Why do I know that's the case? From the last lesson, we said that reduction half reactions always have the electrons on the reactant side because something is gaining electrons. So because, as per the name, it says reduction potentials. So everything here is undergoing, reduction. The nice thing about this table is that you are literally comparing them. You're comparing things and you're trying to find out the relative oxidizing and reducing ability. So I know what I said just now was not English. I'm going to make this make sense for us quickly so that we can start solving questions. So if you can remember our question, the question that we did was this. We did zinc, we did HCl plus zinc, right? And we can see that H goes from this, it does this, it does 2H1 when it's balanced, 2 H cations plus 2 electrons, that gives us 2H2. And zinc's half reaction would be Zn is equal to Zn plus 2. So this is our reduction reaction and this is our oxidation reaction. You will see these two reactions also in your reduction potential table, exactly as we found it in the previous page. Zn plus 2E is equal to Zn, but this is the reduction reaction. And for a hydrogen, 2H plus 2E is equal to H2. So you'll find these two reactions here. And what it says here, it says on the side by these arrows, increasing oxidizing ability. So that means that the higher up we go, the more likely it is to cause something to reduce. So if it to cause something to oxidize in ability. So the higher up we go, and we can see comparing zinc and hydrogen, since it's higher up than zinc, it's more likely to cause something to oxidize. So hydrogen will oxidize zinc. Anyway, you don't need to even know all this. I apologize for getting too deep into it. All this to say that you don't even need this to know what's happening. It's just a nice thing to look at and a nice thing to know if you're a nerd or you're a bit obsessive about the subject like I was. But you don't need to know it now. We'll cross that bridge when we get there next year. Let's start solving questions. We're going to be solving a question from November 2022, grade 11. Let's see what it's saying. Question 7. Should I solve this one? Because this one is not a basic one. Let me see my other questions that I have. This one looks basic. Yeah, this one looks basic. Let's deal with the basic question first. No offense to the other questions, but this is a nice starting point. So it says the lab assistant stored zinc sulfate, ZnSO4, in an aluminium container. So aluminium just by itself. After a while, the teacher notices that the aluminium container is eroding, and she suspects a redox reaction. It's not good to be suspicious of everything. So let's see if what this teacher is saying, what this teacher is surmising, is it true? The teacher writes down the following unbalanced reaction. ZnSO4 plus Al produces Al2SO4 plus zinc, or if you want to do the naming, zinc sulfate plus aluminium gives or produces aluminium sulfate plus zinc. Now, an easy telltale sign to see that this is a redox reaction is you can see that something was by itself and now it is taken. It was single, now it's taken. Single, married. Bachelor, married man. The same thing here. You can see that we used to be together, things didn't work out, now we divorced. So when you see something move or transition from being an element to a compound, to being inside a compound, or something that was in a compound and divorced and now is an element by itself, then that is the easiest telltale for you to know that this is a redox reaction, that there has been a transfer of electrons that have taken place, that have changed the charge of my of whatever I'm looking at. So define a redox reaction. Again, not the formal definition, it's just a transfer of electrons. Let's start writing out these answers. So for 8.1, redox reaction, transfer of electrons. Now the formal definitions, you are gonna do that. You'll just memorize it before you write the paper, and then then you forget it straight after you write it. I hope you don't, but that's normally the case. You don't need to know the formal definition, just understand what's happening. Calculate 8.2.1 the oxidation half reaction for this reaction. Well, first let's break down what's happening in this reaction before we even get to that point. Let's break down what is happening here. So we have zinc sulfate plus aluminium, and we're saying that this produces aluminium sulfate plus zinc. So what we're going to do here is we're going to divide it into its respective ions, into their respective ions. So we have zinc 2 plus. I know that it is zinc 2 plus because sulfate, the polyatomic ions that I was told to memorize in grade 10, I know that sulfate is 2 minus. So if sulfate is 2 minus, this has to be 2 plus, so that's why I don't see anything at those positions. So I have that plus aluminium, which has a neutral charge, a charge of 0, and this produces Al3 plus. Why do I know it's Al3 plus? Because this 3 that ended up as a subscript came from the charge that was on top here. So Al3 plus SO4 2 minus plus zinc, which is now a neutrally charged species in our reaction. So let's track the change. Let's see if anything has changed. Well, firstly, I can see that there's no change by sulfate, so that's already ruled out. Now let's look at zinc. We can see the journey that zinc has embarked on. It was 2 plus and now it is Zn. And the journey that aluminium went on, it was neutral and now it is Al3 plus. So let's look at what has happened here by looking at it carefully. What happened here was it used to be positively charged, now it is more negative. So from 2 to 0, it became more negative. And for something to become more negative or closer to being negative, it would mean that we have gained electrons. And gained electrons is an easier way of saying it has been reduced or it's undergoing reduction. Al went to Al3 plus, it became more positive. This is something we talked about. The words that I'm using, more positive, more negative, these are things we did in the previous lesson. So from Al to Al3 plus, it became more positive, so it lost electrons to become more positive. And losing electrons, say it in a easier way or in a shorter way, we say it has undergone oxidation or it has been oxidized. So this is what we get here now. And now we are well equipped to start solving the question because we know what's been oxidized, we know it's been reduced because we divided each thing in our reaction into its individual ions. So now we are ready. Here we say bring it on to whatever the question has to throw at us. Yes. So 8.2.1, the oxidation half reaction. We said the aluminium undergoes oxidation. It has lost electrons. So we have to write the loss of electrons on the product side. Al is equal to Al3 plus 3 electrons. That's how it got 3 plus. It lost 3 electrons. Then we move on to 8.2.2. 8.2.2, the reduction half reaction. We know that Zn or zinc has undergone reduction. Gaining electrons, you gain electrons on the reactant side, plus 2 electrons, and I get Zn. Then it says to write down a balanced net reaction. To write down the balanced net reaction, as I did before when we were doing the checklist, if you want to do the balanced net reaction, you have to look at both the oxidation and reduction half reactions and then try to balance the amount of electrons. Try to balance the amount of electrons. To do this is quite easy. We can see that here I have 3 electrons and here I have 2. So the lowest common factor here is going to be 6. So we can say multiply this at the top by 2 and multiply this at the bottom by 3. So that's what we're going to do. So let's write out how those reactions are going to look like now. Multiply the top one by 2 and the bottom by 3. Let me use this color. So 2 and 3. And I think you understand why I'm doing it like this. So 2 Al, that is going to give me 2, and this is going to be 6. So 6 electrons plus 2 Al3 plus. For the reduction half reaction, we're going to have 3 here, 6 and 3. Okay, so 6 electrons here, we have 3 Zn, Zn2 plus when you balance it. So now we can see that we have electrons on both sides of the reaction. Let's combine these reactions together. When we combine them, we get this. We get 2Al plus 3Zn plus 6 electrons. This is going to give us 2Al3 plus 6E plus 3Zn. Now it comes time to cancel. We can cancel the electrons that are the same on both sides. So our net reaction is going to be 2Al plus 3Zn2 plus gives or produces 2Al3 plus 3Zn. Now you might ask, do you have to write all of this down? Well, I'd say if you've just started this topic and you have, then you should. Your answer can obviously be shorter, and as always, since you are heading into matric, it's better that you write more instead of writing less with that risk of you losing out on a few marks. It's better you write more. Now the last question, 8.3. It says identify the reducing agent. We know that this word, since we talked about it, this word reducing agent means that we're looking for the thing that is undergoing oxidation. If it's a reducing agent, if it causes something else to reduce, then itself it is undergoing oxidation. So what do we know that is undergoing oxidation? From the previous questions, we know that aluminium is undergoing oxidation. So if aluminium is undergoing oxidation, aluminium is the reducing reagent. So therefore, aluminium, or the Americans aluminum is undergoing or is the reducing reagent. Let me not do too much. Is the reducing agent. Right, that's that on that. Very easy question, 9 out of 9. Easy to get. It covers everything that we've talked about: defining it, knowing how to make a half reaction, knowing how to divide your equation into individual ions, balancing it to make a net reaction, and then understanding how to identify a reducing agent. That's that on that. Next video, we're going to do the more complex questions, and then we're going to wrap up this because this is a very easy topic. Tot ziens. Bye-bye.